So today we are going to solve this problem, min cost claiming stay, and it was 746. So in this problem we have stays and each stay has a cost. Okay, each stay has a cost. Okay, so when we stand on a stay we pay that cost. So from any step we can move one step forward or two step forward. We want to reach the top spending the minimum money. So one step is next stage and two step means skip one stage. So okay, see, we have cost of array is 10, 15 and 20. Okay, so this is 0 1 2. So if we start with one step more, if we move one with one step, see, first it's 0, we start with step 0, and next is step 1, next is step 2, and then we go to the top. Okay, so steps taken is 0 and 1, one step, 1 or 2, one step. Okay, so 10 place 15 place 20, so it was 43. Next part we jump 2 step. Okay, this is first part, and next we start 0 to 2. Okay, next is stop. So 0 to 2 we step 2, 2 steps jump. So 10 plus 20, it was 30. Okay, next is start from step 1. If we start from step 1, so step 1 to step 2, so it was 1, and next is stop, so the cost is 15. So the minimum of this is 43, 30 and 15, so the minimum is 15. Okay, so the answer is 15. If we have 1 2 1 5 0 1 2 3, okay, so see, first step, always first one step. Okay, so 0 0 1 2 3, next stop. So 1 place 1 plus 1 plus 1. Okay, so 1 plus 2 plus 1 plus 5, it was 9. Next is B part, mixed steps. Okay, 0 to 2 top, 0 to 2 top, 1 plus 1 is 2, so the minimum is 2 only. Okay, so see, one step means go to the next step, two step means skip one step and land on the next, like this. 0 to 2 we will skip this and we land here. Okay, land to the next. So every time we land on a stay we pay it cost, so we try different path and choose the one with minimum total cost. Okay, so let's try the small example. If we have cost of array like 10 15 20, so let's calculate 0 1 2. So min cost of 0, we have two options, one step or two step. If we go through one step, min cost of 1, we have 2, one step two step, min cost of 2 value is 20, min cost of 3 is out of bound, so the value is 0. This min cost of 2, if we go through step, we have min cost of 3, the value is 0. Okay, so see, min cost of 2 we pay 20. Okay, to jump to the top, so the cost is 20. So min cost of 1 we pay 15, so we have we have to decide, we have two choice. Go one step with min cost of 20, we go two step min cost of 3, that is 0. So how can we define min cost of 1? Min cost of 1 is equal to 15, value is 15, and plus minimum of 20 and 0. Which one is minimum? That was 0, so the answer is 15. So we are going to return here 15 only. So min cost of 0 we pay 10. Okay, so we have to choice, go one step with 15 or go two step with 20. If we have min cost of 10 plus minimum of 15 comma 20, so the minimum is 15. So we will return here from 15, in both 15 is minimum, so 15 plus 10, 15 plus 10 is 25. Okay, so compare from starting from 0 to 1. Let's compare 0. At start 0 we have 25, at start 1 we have 15. At start 0 we have 25, start 1 we have 15. So the minimum cost is 15, it was 25, it was 15, it was 20, it was 0, and it was 0, it was 20. Okay. So from any step we try to jump two jumps, one step or two step. Each node in the tree show cost. If we start from that step, the answer is on the part that lead to the minimum total cost to reach the top. Okay, so let's take another example. If we have numbers of value like cost 1 to 1 and 5, 0 1 2 3, so let's make a tree. Min cost of 0, if we go to one step, min cost of 1, if we go to two step, min cost of 2, min cost of 2. If we have this set also, we have two options, we go to one step, it min cost of 1 2, so min cost of 3. Okay, next we have two options, min cost of 3, that was 5, min cost of 4, that was 0 out of 1. So min of 3, in this also we have 5, min cost of 3 0, min cost of 3 0, min cost of 4 0. So see, min cost of 4 is top, so the cost is 0. Min cost of 3 is there, we pay 5 to jump to the top, so the cost is 5. Next, min cost of 2, min cost of 2, we have to pay 1, we go two steps, we go to two steps. Okay, cost of 3, that was 5, and cost of yes, so min have 2, yes, in this we have to go one step, 3 is 5 and 4 is 0. Okay, 5 and 0, let's calculate first. Min cost of 2 is 1 plus 5 comma 0, this one. Minimum is 0, let's return 1. So it min cost of 1, min cost of 1, we have two options, go one step or go two steps. So the minimum of this is 1 plus 1, it was 3. Let's write a code. Min cost of 1 is 2 plus minimum of 1 comma 5 is 3. So the minimum of both is 1 and 5, so value is 2. Okay, next, mean cost of 0 is 1 place minimum of 3 comma 1, it was 2. So let's compare. We start from 0 to 2. Start with 0 to 2. Start 1 with min cost of, it was out of bound 3. Next answer is 2. So next we come, it's give us, it was 5. Yes, it was 5 and it was 0, so the minimum of this is 0, so 2 is 1 and it become 5, so the minimum is 2, it's written plus 1 3, so the cost is 2, it was 1 and 5 0. Each node start index min cost values starting from that stage, so leave node is 0 only. Yes, let's take another example. Small tree, cost of 5 comma 10, 0 and 1. So we have two options, min cost 0, 1 step, min cost 1, that was 10, 2 step, min cost of 2, out of bound, so here we are going to return 0, so min cost 2, cost of 0 to it's 0, there was no value, so min cost of 1 stay 1, we will pay 10, jump to the cost 10, so 0, which one is minimum? 0, it was written 10, so the minimum is 0, so the answer is 5. Okay, it was 10 0 5. Yes, from every step we tried to jump 1 step or 2 step. Each node in the tree show the minimum cost starting from that step, then we pick the cheapest path, okay, to the reach the top. So let's write the code. So see, so I want a function that tells me minimum cost to reach top from the stair I. Each stair we call itself from next stair. This will from our recursion tree. So first I want a function only, int solve vector int cost and int I. Okay, next see, suppose I is 2. Okay, suppose I is equal to 2. Okay, we all passed last step, we all at top, so cost is 0. So cost is 0 because top has no cost, so this top recursion otherwise program will keep calling infinite, so value is 0. If they go out of bound, we have to return 0. So if I is greater than or equal to cost dot size, return 0. Okay, I have to return 0. Next, see, next is if I is equal to 0, that was 5. Okay, the current state count is 5. Okay, current state count is 5. If I move one step next step, I place 1, it equal to 1, the value is 10. So I pay current cost, that was 5, plus future cost from solve of 1. Okay, from solve of 1. So int 1 step is equal to cost of I plus solve of cost comma I plus 1 plus 1. Next, for 2 step in cost of I plus solve of cost comma I plus 2. So say I is 0, current cost is 10. If I move 2 step, let's take another example. Let's take this example, 1 2 1 5, 1 2 1 5. Okay, 1 2 3. Now let's take that example only. See this example only. I is 0, current cost is let's take this example, 10 15 20. Okay, 0 1 2. I is 0, so current cost is 10. If I move 2 step, okay, next is I plus 2, it was 2. So I pay current cost 10 plus future cost from solve of 2. So right child of solve of 0, right child is 10 plus solve of 2. Okay, next return in step 2 step. Return main step and this 2 step. Next we have to return minimum of solve of cost of 0 and solve of cost of 1. What it was telling. Gosh, what happened? Just a second. Unexpected error. Okay. I think I have to place cost of I solve 2 So see why this means. So solve of 0 is 25 and solve of 1 is 15. So so the minimum of this is 25 comma 15. So we have to return the minimum, that was 15. So the answer is 15. Okay, so see, recursion can be slow. We cannot use recursion can be slow. Okay, for this we are going to use memorization. We convert this code in memorization. So we use, so let's see, so we just use so see, we use maps to store already solved states. If a state is solved, we return memo value. Do not recalculate that. Okay, we not recalculate that. So if, just a minute, if, see what we are doing in recursion. If I am at past, the last step we cost is 0. We trying one step to pick current state. Future cost, we try moving 2 step. We pick current state plus future cost. We pick the cheaper and return minimum left or right. Okay, so we cannot use recursion can be slow. So for that we are going to use memorization. Once we calculate the answer, we just store and we return that answer. In future we do not recalculate that again. Okay, so if we have, see, we just store the answer. We just store answer. Memo dot count of I, so return memo of I. One step, two step. Next what we do, memo of I is equal to minimum we just return memo of I. Memo of I is equal to, yes, see, we have cost is 10, 15, 20. Okay, solve of 0, we have two options, solve of 1 and solve of 2. So solve of 1, solve of 2 is memo of 2 is 20. Solve of 0 cost solve of, this is also two option, 2 and 3. If you call this, so we just found, we stored answer and we have to return here directly. Okay, so we don't calculate it again and again. Memo helps avoid repeated work. Okay, like this, solve of 2, call twice, memo store value and reuse. So without memo, recursion grow exponentially. Recursion calls stack grow even with memo. Stack overflow हो सकता है for every last stage array of 10 to the power 5. Recursion deep is equal to n. The program make cache. Okay. For best approach is tabulation. Use bottom up row fills DPRA. No recursion stack. Safer for big input. Okay. So for the time complexity is big of n and space is big of n. Or even more optimization, it was 1. So let's write in tabulation. So now let's write. See, we already know from recursion that was for every step we have two choice: go with one step or go with two steps. Okay, and we want a minimum total cost. Okay, and we want total minimum cost. So instead of starting from bottom, we think if I already know the minimum cost from future states, then current state cost is easy to calculate. So we go last stage backward. Okay, because future already solved, so current easy. So the formula of this is dp of I is cost of I plus minimum cost from next day or cost from next to next day. Okay, means standing at stair I, so we have to pay cost of I. Choose cheaper paths between I plus 1 or I plus 2. Okay, so you have to choose cheaper paths from I plus 1 to I plus 2. If we have 15, 20, 0, 1, 2, so we make DP array. First it was empty DP array 0, 0, 0, 0, 0, because n plus 2 or n plus 1 we will do n plus 2. 0, 1, 2, 3, 4, n plus 2. Okay, extra space for safety I plus 1 to I plus access, we have to access now. If I is equal to 2, if I is equal to 2, okay, future cost is dp of 3 is 0, so 3 and 4, dp of 3 is 0 and dp of 4 is 0. So dp of 2 is 20 and dp of 2 is 20. So place minimum of 0, 0, it was 20 only. Okay, so see, it's become, so we write here 20. Okay, if I comes here, I is 15. If I is 15 and stay value is 15, I is 1 and stay value is 15. Okay, so dp of 2 is 20 and dp of 3 is 0. So dp of 1 is equal to 15 plus minimum of 20, 0. So dp of 1 is 15. Okay, so right here 15. Okay, next I is 0, I comes here and value is 10, stay value is 10. Okay, so dp of 1 is 15 and dp of 2 is 20. So dp of 0 equal to 10 plus minimum of 15, 20. So the minimum is 15 plus 10, So dp of 0 is 25. Okay, so it's become 25. So we start from step 0, step 1. We have to start from step 0, step 1. So dp of minimum, wait, so the minimum of dp of 0, dp of 1, minimum of both in both is 25, 15. So the minimum is 15, so the answer is 15. Okay, so let's write down the code. First we comment all this. We need number of stairs, so int n is equal to cost dot size. Okay, next we need we need this. Okay, we have to store the minimum cost of each stair, so why we are going to use n plus 2. So we access I plus 1 and I plus 2 for extra space even for crash. We starting from last now, that's why. So make a vector vector, and we have to create dp vector n plus 2 and initializing with 0. We fill this with 0. Okay, next row. I want future footer, so for int I is equal to n, I is greater than or equal to 0, minus. Next we have to calculate. I stand on stair I. See, I was stand on stair I must pay the cost of I. So we check next stair cost. Yeah, skip next stair cost. So we choose smaller further and add. So dp of I is equal to minimum of dp of I plus 1 dp of I plus 1 dp of I plus 2 plus cost of I. Okay, now we just return minimum of dp of 0 or dp of 1. We have to return this. Okay, so we choose cheaper starting point. We have to choose 0 or 1, which one is the minimum. Okay, so the recursion idea same, but we store answer in dp. So we solve from top bottom reverse order. Each stair use future value. Okay, let's try one. What happened? dp of minna and dp of I. Cost n little dp of this one. I is n minus 1. Sorry, we have to write n minus 1. Now what happened? 1. What happened? What's wrong? Output is 0. Expected output is 15. 2. dp of I is equal to cost of, I have to write cost of I. dp of I, formula mistake, sorry. Cost of I plus minimum of dp of I plus 1 dp of I plus 2. That's it. So see, in this we have added cost of I only in second option, but when we stand on a step we must always pay the current cost also. So that's only.